Prototypes, prototypal inheritance, and prototype chaining. What does all of that mean? Well, that's what this video is all about. Alright, so as I promised in the previous video, this video is going to be all about prototypes and how to set up prototype chains correctly. If you haven't checked out the previous video and you're not super comfortable with the keyword this, I recommend that you go check that out first before you watch this one. I'll leave a link to that up in the corner for you. Now you might be wondering, why are we learning about prototypes if now with ES6 we have the class syntax? Well, as you've probably read, the class syntax is just a very thin wrapper around prototypes, and everything under the hood is still using prototypes. So understanding how prototypes work and how to make use of them will really enhance your JavaScript knowledge. So with that out of the way, let's jump into learning about prototypes. Alright, so before we get into how prototypes work, let's look at what they are, how we use them, and why we use them. Alright, so let's start off with an object literal of Jedi. And the Jedi have a property force, which is true. So the Jedi can use a force. Then we'll add another object literal called ob1. And he has a lightsaber, and this is blue. So now we have two separate object literals, and at the moment they're not related to one another. And so if we do console log ob1.force and we run that, we get undefined because ob1 doesn't have a property called force. So what we can do is we can set ob1's prototype to Jedi. So that would look like this: object.set prototype of, and then we take the object whose prototype we want to set, in this case ob1. Then we take the object that we want to be the prototype, in this case Jedi. And so now if we do console log ob1 force and we run this, first we get undefined because that is being called here, and then we get true. So how are we getting true now? Because if we go and check whether or not ob1 has the property force, well, we can do that by console logging ob1. So let's run that. You can see that ob1 still only has the property lightsaber. Alright, so let's quickly get rid of these console log statements because we don't need them anymore. One other way that you can check whether or not an object has a property is using the hasOwnProperty method. And so we'll check for force here. And if we now run that, we get false because ob1 doesn't have its own property force. But if we do lightsaber here and we run that, we get true because ob1 does have a property lightsaber. So it's obvious that ob1 doesn't have a property force, but again, when we access ob1.force, we do get true. So it is accessing this property somehow. So where is it accessing that property? Well, on this line, we set the prototype of ob1 to Jedi. So if we go check ob1's prototype, then we might find the answer. So to quickly check what's on ob1's prototype, we can do .__proto__. And if we now run this, you'll see that that returns an object that is force true. And what you'll see is that that is actually just this object here. And we can confirm that by saying, is ob1's prototype equal to Jedi? And so let's run that, and that returns true. So you can see that we have successfully set ob1's prototype to Jedi. So when we do ob1 force, what JavaScript is doing is it goes and checks the ob1 object for a property force. And because it can't find one, it then goes and checks ob1's prototype, which is Jedi, and there it finds a property force. And so true is then the value that it returns when we do console log ob1.force. So now the cool thing is we can go update the Jedi's property force, and it'll also update for ob1. I'll quickly demonstrate that. So I'm going to do this after the set prototype object so that you can see that OB1's prototype really is referencing the Jedi object and it's not just creating a copy. So here if I say Jedi.force is equal to false, when we run this, OB1.force returns false. Alright, so let's have a look at how prototypes work in the context of constructor functions. So let's get rid of all of this. Alright, so let's write a simple constructor function. The function character, and that'll take a name and a force user. And so we'll say this name is equal to name, this force user is equal to force user. So force user will just be a boolean to say, can this character use the force or not? So then we can create a new instance. So that's pretty standard. So if we now console log Yoda and we run that, we get exactly what we expect. The character object that has the name Yoda and a force user that is true. So let's say that we wanted to create a method called useForce. And so that'll first check whether or not the character is a force user or not, and if they are, it'll console log this character's name, use the force. The common way of doing that would be setting the useForce method on the character's prototype object. Let me show you what I mean. So we can do character.prototype.useForce and set that equal to a new function. So we first want to check whether or not they're a force user. So if not a force user, and else. So now we can go say Yoda dot use force, and let's run that. I'll say Yoda used the force because Yoda is a force user. But you might be thinking, wait, we never set the use force method on the Yoda object, and you'd be right. So how does Yoda have access to the use force method? Well, just like before, we can console log Yoda dot has an property use force, and that will return false. So it's indeed true that Yoda doesn't have a method use force. So how are we accessing this use force method? Well, if Yoda doesn't have the method use force, maybe its prototype does. So let's go check that out. __ proto __, and let's log that out. And there we can see that Yoda's prototype indeed does have a use force method. So you might think, why go through all of this effort with prototypes if we could have just defined this method in the constructor function here? Well, there are a number of reasons. So the first reason being is if we did say this.useForce is equal to this function here, and then we'd get rid of this here, then every time that we create a new object, a duplicate function is redefined. You can see that if we say const ob1 is equal to new character ob1 true, then we can compare whether or not the functions are actually the same. And then we'll do console.log Yoda.useForce is equal to ob1.useForce. We'll get rid of this console log statement. So let's run that now, and we get false. The reason why we get false is because they're actually not the same function, they're duplicate functions, because we defined it in the constructor method, and when we create a new object here and here, we're actually just creating a duplicate function. So if we now compare this to defining useForce on the prototype object, like so, character.prototype.useForce is equal to this function, and then we'll get rid of this here. If we now run this, and so now we get true. And the reason is because when we're assigning the method to the prototype object, neither Yoda or Obi-Wan actually has a useForce method. They're just referencing the useForce method on their prototype. Another reason why it's beneficial to define the methods on the prototype object is because it allows us to make use of prototypal inheritance, but that concept we'll get to a little bit later in this video. Now, I fully understand if this is still relatively unclear, because it is a difficult concept to grasp. And so to help you understand it a bit better, I've created some visual diagrams that'll explain it in a visual way. Okay, so just a quick note, I have taken quite a bit of inspiration for my visual explanation from Kenneth Kin Lum's blog. Now, if you're looking for an excellent blog post that explains how prototypal inheritance works with some great diagrams, I highly recommend that you go read this article. I'll leave a link down in the bottom of the video description for you to go check out. So let's have a look step by step what's happening when we create a constructor function. So we'll start off by defining a constructor function here, and that creates a constructor function object, because in JavaScript all functions are objects. The next important thing to know is that all functions have a prototype property, and that prototype property is an object. Now this object has two properties by default, a constructor property and a proto property. Now for right now we're most interested in the constructor property. The constructor property points back to the original constructor function. So you can see constructor prototype dot constructor is equal to constructor. Or visually seen, this constructor function has a property prototype, which is an object that has a property constructor, which references back to the constructor function. Now why this is important will be clear in just a moment. Now, if we create an instance using the new keyword, like this, new constructor, then we create an instance of the constructor function over here. Now, by default, all objects have a proto property. Now, that property references the prototype object of the function that constructed the instance. Now, in code, that would be the instance object dot proto is equal to the constructor dot prototype. Visually, here you can see that the proto property references this prototype object, and this prototype object belongs to the constructor function that constructed the instance object. Alright, so as an example, when we call instance object.constructor, what's happening is JavaScript is going to go to the instance object and look for a property constructor. When it can't find one, it then goes and checks the prototype of instance object, which is this here, and there it can find a constructor property. That constructor property has a value, which is this constructor function, and so that's the value that's going to be returned from this code over here. Alright, so now that we have a better visual understanding of how prototypes work, let's have a look at prototypal inheritance. So let's say that we have a Jedi constructor function and a character constructor function, and we want the Jedi object to have all of the methods that the character objects have, because the Jedis are a more specialized form of a character. So for that relationship to exist, we need to find a way to link this Jedi constructor function to the character constructor function. So let's have a look at the common way that people will do this. Now this might look a little bit weird, but what we're actually doing is we're overriding the Jedi's prototype object with a new instance of character. So you can see what's happening here. We do new character, which creates an instance of character here. Now, as we learned earlier, the prototype of a new instance always references the prototype object of its constructor function. So now we're linking this constructor function to this constructor function through their prototypes. So if we now compare these two prototype objects, we'll see that this Jedi's prototype object is missing a constructor property. And the reason why is this prototype object is actually just an instance of character, and instance objects don't have a constructor property. So the next step is adding a constructor property to the Jedi's prototype object. So we can do that relatively simply by saying Jedi.prototype.constructor is equal to Jedi. And that creates that link back to here. So this looks very much like where we started, except for you can see that there is now a link between the Jedi constructor function and the character constructor function through their prototype objects. And so now if we wanted to create an instance of Jedi, we can do that simply by saying new Jedi, like so. And as previously discussed, any instance object will have a prototype that references the prototype object of its constructor. And so you can see that the Anakin Skywalker object's prototype references this prototype object, and that object's prototype references this prototype object. And so you can see how we're chaining these together, and that's how we get the term prototype chain. Okay, so now that we have our inheritance set up, let's have a look at how prototypal inheritance works in practice. So let's say that all Jedi should have the ability to do a force jump. So let's add a method to the Jedi's prototype object called force jump. So we do Jedi.prototype.forceJump is equal to a particular function. So you can see that now we have a method on this prototype object called force jump. Similarly, let's say that all of the characters should have a method called walk. So we'll add a method walk to the prototype object here by saying character.prototype.walk is equal to function. So what happens when we call Anakin Skywalker.forceJump? JavaScript will go to the Anakin Skywalker object and look for a method called forceJump. Because it can't find one, it'll then go and look at Anakin Skywalker's prototype, which is this object over here. On this object, it does find a method called forceJump, and then it executes that force jump. In the case where we call Anakin Skywalker.walk, JavaScript will go look at the Anakin Skywalker object. The Anakin Skywalker object doesn't have a method walk, so JavaScript then goes and looks at Anakin Skywalker's prototype, which is this object. This object also doesn't have a method walk, and therefore it then goes and looks at that object's prototype, which is this object over here. This object does have a walk method, and so it's that method that then gets executed. This also explains why it's a good idea to put your methods on the prototype object rather than on the constructor function, because as JavaScript is walking through the prototype chain to find the method or property that you're after, it doesn't actually go and check the constructor functions, it only checks the prototypes. So when you're calling a property or method like this, unless the property or method is on the object instance itself or one of the prototypes in the prototype chain, JavaScript will not be able to find the property or method. Now that you're hopefully comfortable with how prototypal inheritance works on a conceptual level, I'd like to take you through a coding example to show exactly how to implement prototypal inheritance. Alright, so let's walk through the steps of the visual example. In the visual example, we had two constructor functions, a Jedi constructor function and a character constructor function. So let's create those quickly. Alright, so now we have two separate constructor functions, a character constructor function and the Jedi constructor function. For Jedi to inherit from character, we need to set the Jedi prototype to a new instance of character. So let's do that. Jedi.prototype is equal to new character. So let's console log the Jedi prototype quickly. So here we can see that the Jedi prototype is indeed a new instance of character. Because we didn't pass in any arguments, the name and the force user are both undefined. Now, it's important to note for our prototype, we don't really need a name or force user property. So at the end of the video, I'll show you how we can rewrite our code slightly so that we don't get these unnecessary properties. But for now, you can see that the Jedi prototype doesn't have a constructor property. So we need to go and add one. So we need to add the constructor to the Jedi's prototype object. So we'll go Jedi.prototype.constructor. and the constructor property should reference the constructor function, and in this case that is Jedi. So now if we run this, you can see that our Jedi prototype object has a property constructor which references the Jedi constructor function. So now we have a prototype chain between Jedi and character. So let's create a new instance of Jedi and see what happens. So we'll go const Anakin is equal to new Jedi, name is Anakin, lightsaber color is blue. There we go. And then we'll console log Anakin. So we can see that we now have a new Jedi instance with the name Anakin and a lightsaber color that is blue. And that's great, but we don't have the Force user property set. And that's because we're not setting it in the Jedi's constructor. So how do we make sure that all of these properties get set in our Jedi constructor as well? Well, that's where our good friend call or apply can come into play. In this case, we're going to use the call method. And so what we're going to do is character.call this, and then we pass in the value that we want the name to be. In this case, it's going to be the same as this name. We'll just pass in name, and then we want to pass in what we want the Force user to be. And because all Jedis are Force users, we'll say true. If you're not sure about what the call method is doing in this case, or how the this keyword is functioning in this context, then I recommend again that you go check out my this keyword video. So I'll just leave you a link up here if you want to check that out. So because we're calling the constructor function here with the call method, and we're passing in the name value, we don't really need this line anymore, so we can get rid of it. So now if we run this, we'll see that our Anakin object now has a Force user property. Now that our relationship is fully set up, let's have a look at how we can use prototypal inheritance in this case. So in our visual example, Jedi had a method called force jump and character had a method called walk. So let's add those to their respective prototype objects. So character.prototype.walk is equal to a function, and now we'll make that function output something, and we'll add the force jump method to the Jedi's prototype object now. So now let's try execute these methods. So Anakin.walk and Anakin.force jump. Let's run this. It says here Anakin went for a walk and Anakin force jumped 20 meters high. Now what's interesting to note is that we defined these methods after we created our Anakin instance. And again, this works because these methods are on prototype objects that are within Anakin's prototype chain. So we can also go ahead and add another instance, like so. And then if we were to say Yoda.force jump, you'll see that that'll now also work. Anakin went for a walk, Anakin force jumped 20 meters high, and Yoda force jumped 20 meters high. Now let's add an instance of the character object, so const jar binks equal to new character. So here we're passing in Jar Jar Binks as the name and false because Jar Jar Binks isn't a Force user. And now we can say Jar Jar Binks dot walk, and we'll run this. And it says Jar Jar Binks went for a walk, but because Jar Jar Binks is only a character and not a Jedi, it won't be inheriting from the Jedi's prototype object. And so if we say Jar Jar Binks dot force jump, we'll see what happens now. We get an error because it says that Jar Jar Binks.force jump is not a function. So this means that force jump is not a method on the JavaBinks object, nor is it a method on any of the prototype objects within JavaBinks' prototype chain. So hopefully this example helps illustrate how prototypal inheritance is implemented in code. But before we finish up, I want to quickly go back to something that I was saying earlier in the video. So let's quickly comment this out and we go back up here. Now, if we console log Jedi's prototype, you might remember how I was saying that Jedi's prototype object has two unnecessary properties on it, name and force user. And I also said that with a small modification to our code, we can avoid setting these properties on Jedi's prototype object. So let's have a look at how we can accomplish that. The reason why I said that I bring this up at the end of the video is because it brings up new syntax that we haven't really covered, and that's object.create. So let's look at a really quick example of how we can use object.create to replace this line here. If we write object.create character.prototype, and now we run this, you'll see that now we don't have those unnecessary properties anymore. And if we now go and uncomment this, and we run this, you'll see that our prototype chains are still set up correctly. Now you might be wondering, what exactly does object.create do? Well, object.create will be the topic of our next video. Alright, so that brings us to the end of this video. Now, if you're still not 100% comfortable with prototypes, that's okay, because prototypes are one of the most difficult concepts to understand when it comes to JavaScript. But once you understand it, the language really starts opening up and your confidence in JavaScript significantly increases. As always, if you have any questions about prototypes, leave them in the comments below and I'll be more than happy to answer them for you. But for now, I'll catch you later.